Well, welcome back to the build of this JYETech oscilloscope, which is there. Well, we've made some progress. Now I've just got to plug my camera in because I think the battery's about to die if I don't. Right, that's better. Okay, so what have I done since the last video? Well, the whole board is completed. The first problem I had was power supply, because I did buy the power supply recommended on Banggood, which was this thing, which I've shown you before, which frankly I don't trust. I just don't want to shove 240 volts through that and not expect the place to be blown up. I mean, they've not even cut off the ends of the pins on the through-hole components. I just don't like it, don't trust it, don't want to use it. So what I did is I found another power supply, which is a good quality one, with a UK socket on it as well, because the one I got from Banggood is actually a European socket. And I took the barrel connector off the Banggood one, spliced it onto the power supply I found, so I've got a 9-volt supply, so that's all good to go. So that's what I've done there. The other thing I've done is I've prepared the LCD board by putting the connecting pins on there, and there is just soldered on, no problems at all. So I've done that. I've not plugged it in at all yet. Not plugged it in at all. The only other thing I did was here it tells you to apply your 9 volts, so I do know that's working. And then check the voltage at test point 22, which is just there. And as long as you get 3.3 volts, or around 3.3 volts, I think I'll go about 3.2, then you're good to go. So once you've done that, once you've tested you've got the right voltage at that test point, then you have to go down to JP4, jumper 4, and bridge it with solder, which I've done. So there's a bit of a blob of solder there. So the next thing to do is to plug in the LCD and then connect power to it and see if it works. So let's do that. As Dave Jones from EEV blog says, let's see if we get magic smoke. Onto the camera just a bit. So that all lines up very neatly. So without touching the LCD, I'm just going to try and press down. There we go. Click. And those two pins is reasonably firm in there, so that's okay. It has got a screen protector on it still, by the way. Yeah. So that's the board, and the next thing to do is to see whether or not it powers up. I think. So there's me 9 volts, and that goes in there. What do we reckon after all this? Is it going to work, or is it going to blow up? Let's see. Oh, we have life. Hooray! There we go. And we have a trace. It is running. I am dead chuffed about that. We have a trace. Let's try some of the switches. Bearing in mind I don't really know what I'm doing. Let's see, we've got voltage here. Yeah, so 2 volts as shown there, 0.2 volts, 20 millivolts, so that seems to work. What's this, ground AC DC? Yeah, it's making stuff happen, and if it makes stuff happen, then booting. That might have been me touching the power supply there. Let's see. It rebooted itself for some reason. Not sure what was going on there. Let's take this screen protector off. You can have a better, cleaner look at it. There we go. That is a very dinky little oscilloscope. What does actually work? How about that? I'm pretty chuffed with that, as you might be telling. So there we go. That is the oscilloscope completed and working. Oops. It's a bit of a shame I haven't got a damn clue what to do with it, but never mind. At least we know that we can build these things without making too much of a hash of it. So yeah, pretty happy with that. I think the next thing to do before we screw this thing up completely is to stick it in the case. So let me, there's no on-off button, so it's just a case of unplug it from the supply. Fair enough. So there we go, that's the completed kit. Now the next thing to do is to get into this, which is the case. Get that out of the way. And you see these red pieces of plastic here will go on top of the buttons, so it makes it easier to press. It's all sealed up. Now, if you've not seen these sorts of cases before, basically they are clear acrylic cases, CNC I expect, or laser cut or whatever, I don't know. But here we go, there's the bag of hardware, the nuts and the bolts, and we have the case itself, and you can see it's brown, but actually all of that is little bits there. I'll show you again for those that have not been familiar with them, but actually all of that is, or all that is paper stuck on the acrylic, just to protect it whilst in transit. So you just peel that off and away you go and build up the case. And as you can see, you've got four sides. What have we got? We've got a couple of centerpieces here, oddly enough, identical for the LCD. I'm not entirely sure how this goes, but I'm guessing it will go like that in some shape or form. That kind of looks sensible. It might be these two sandwich the buttons together. I don't know. They never give you instructions for these. There's a little bit of Krypton factor for those of you who know what Krypton factor means. So what I'm going to do is I'm going to put the case together, and I'll show you the finished article, of course. That looks like a complicated piece, doesn't it? Yeah. So not entirely sure how this is going to work, but once it's in the case, it's in the case, and that will be good. So let me put the case together, and once I've done that, I'll come back to you. Right, a bit of an update, actually. 1 minute. There we go. Right, here we go for a bit of an update to the oscilloscope. The last time I left you, I was going to install the case, which I haven't got around to yet. There's all the bits and pieces for the case, of which there are many.
I don't have the answer to that. Is there something else I can help?
No, there isn't. That's Siri kicking off. And Siri is a useless pain in the arse. Pardon my French, but there you go. So, right. Yeah, so I haven't actually put the case together, but I've taken all the paper protection off of it. And here are all the buttons and bits and pieces that need to be installed. So I haven't worked out what to do with the case just yet. The reason being, apart from the fact I've been busy doing other things, so I haven't had a chance to make much of a progress, but one of the other things I had to do was to calibrate the oscilloscope, you're given some instructions on ensuring that the square wave is reading correctly. So that was the thing I had to do. So I'm just trying to get the power supply to the oscilloscope. So let's power up. And there's a reason why I've got all of this set up. In fact, I'll just unplug all of this and start from scratch. I've actually already done the calibration, but I thought you might be interested to see what it's all about. Let's just switch the power supply on, and we should have some life. And there she is, booting up. Okay, one of the things that I noticed, I went on the JYETech website, and they were talking about counterfeits, that when they originally designed this particular oscilloscope, and possibly others as well, but I was just reading up about this one, is that when they originally did it, another organisation or group of individuals or whatever bought an example and basically reverse engineered it and started selling their own versions, also under the JYETech brand, in other words fakes, and they showed you how to spot the difference between the fakes and the originals. I'm not entirely sure, I haven't got a fake here, I could be wrong, I don't want to cast any aspersions, but I have to say that this one is working absolutely perfectly and exactly the same way as it should do. So I don't know, I could be wrong, but that's something to bear in mind. If you go on the JYETech website and have a look and see what you think, whether you think this is a fake or not. And one of the ways of telling is to look on the rear of the board and look at the quality of the font, and there should be a sticker in that location there, but I do have a sticker at the top here, and stuff like that. You know, I don't know. It does seem a very, very nice piece of kit, this one, and I've looked at the components and they seem absolutely identical, so who knows. But there you go, the oscilloscope is most definitely working. So with the very nice instructions that you get with it, which makes me think that this is genuine, or it is a very, very good hack, and I hope it isn't a hack, that it is the real thing. One of the things you have to do is a probe calibration. So you connect your probe, and then you connect the red connection to jumper 2. Now jumper 2 is the one that we bridged with that little piece of well, that was actually a leg from one of the resistors, I think, or something like that, but I just bridged it, and with that little loop of metal there, of wire, so we bridged that, and you can see we've got a square wave come up, and you have to set the I'll go through it with you, or for you, is you have to select Sen 1 there to 0.1 volts. Sen 2 has to be switched to X5 or times 5, I should imagine that is, and the CPL switch, the top one, has to be set to either AC or DC. I've got it set to AC, as you can see here, and once you've done that, you need to adjust the time base, which is there, to 2 milliseconds. And the way you do that is that you, first of all, you can see here you've got an SEL button, which means select, and you just keep pressing that, and you can see there's a blue box round the 0.2 millisecond, or the time period, for want of a better description. Is it the time base? I don't know. So that must be 0.2 milliseconds per division, I should imagine. And then you press the select button, and you can see it moves onto a different thing that you can select. And there it goes up to, that's where you can set one of the trigger levels. And then I imagine it goes over to this one. Does it? Yeah. And then back to the time base or time period. So you select that to 0.2 milliseconds, and then you basically use these two buttons here, that one and that one, to change the time base, and you can see there the time base changing, and I've actually, I see 10 milliseconds is just too much for it, and wipes it out. So I'll bring the time base down, and it tells you to bring it down to 2 milliseconds. That's obviously the so I'm touching components in the back, which is making it go iffy. So that's obviously a period of time which makes it display neatly onto the on the screen. And then once you've set up the switches and the time base, you then use capacitor 4. I would imagine it would be better to use a plastic screwdriver for this, but you've got a variable capacitor there, or variable capacitor trimmer, which is C4, and you basically twist that until you've got the square wave as sharp as you possibly can on the edges. So if I can bring this up and twist it at the same time, if you look at the square wave, you see it's going all to hell now as I twist it. So what you do is you just turn it until you've got it as sharp as you possibly can, which I think is about there. All the flickering you get at the bottom there, you can't get rid of that. In fact, even on the example screen prints they show, you know, it's still a bit iffy at the bottom there. So, you know, that's just the way it is. So that's the oscilloscope calibrated, and it's as simple as that. So it's nice actually. Basically what it's got is it's got a built-in signal generator, which is, you know, generating enough signal, or a square wave just for the purposes of that calibration, and that seems to work very nicely indeed. So yeah, that's setting up the device ready to use. Now I'm not going to use this until I've stuck it in the case with all of these bits and pieces here, and I'm going to work out how to do it, because it doesn't look that straightforward to me. It looks a right caboodle, because basically you've got some of these plastic lids, plastic segments are sort of like, you build it up in stages, and you have to trap the buttons in between, or sandwich them in between certain plates of the case. And there's no instructions, you've got to work it out yourself. I'm sure if I just sit down and think logically enough, I'll work it out in the end. So rather than waste your time, me sat here scratching my head trying to work out how the case goes together, I'm going to do that off camera. And once that's done, I'm going to come back to you, and we'll have a final look at the oscilloscope. Right, well, the case is now finished, fully installed, and here is the finished oscilloscope. And you can see the way that the case is constructed. Again, there's no instructions, but the sides are fairly obvious where they go. You just follow the position of the cutouts, like for the mini USB there, for example. But you bolt the 3 long screws to the base plate. Use 2 nuts, as you can see there, for each one, and that just gives enough clearance from between the base and the main board. And then you use the layers. There's 3 layers, one of which, the first layer, you actually bolt the PC, the LCD board to that layer. Then you put 2 more layers on top, drop the plastic buttons in, and then the final plate on the top. So it's all reasonably straightforward, and it makes for a nice robust unit. And of course the LCD is now protected by that top plastic cover, so reduces the chance of that getting broken considerably. And there you go, that is the construction of this LCD oscilloscope, which cost £23 including the case. So what's that, around $30 I would think, around that period, or possibly a bit less, and that's including shipping, obviously from China. Don't buy the power supply that they recommend, in my view. Don't buy it. I looked at it and I showed it to you earlier in one of the other videos, and it didn't look particularly robust to take mains electricity, particularly over in the UK where we stuff 240 volts into our mains. So I've used a decent quality power supply. Just takes 9 volts, and it is working absolutely fine. All the tests work. I just got to learn how to use it now, and try and see if I can get some real-time use out of it. I've got the instructions, and probably go on YouTube and learn a little bit more about oscilloscopes and how to use them, and that's for another day. But in the meantime, very pleased with that result. It's worked absolutely fine, and yeah, highly recommend one of these. The display is nice and clear. There's some bounce the lights a bit so you can see the beastie in a bit more of its glory. You can see the LCD display there, nice and clear. Got the grid lines there to show the divisions. Yeah, no problems with that at all. Happy with that. Okay, hope you enjoyed these series of videos on completing this kit. Made a bit of a meal of it, I know, but it worked first time. Incidentally, let's put the lights back on. There were a couple of things that I forgot to do. I actually said at one point I got a spare push to make switch. I didn't. I'd forgotten to install that button there, and that's the reset switch. And also these upriser pins, I forgot to install those, so I did those off camera. And you can see that there's actually cutouts to get at those pins there and there. So I'm sure that they'll have a use of some sort. But there you have it. Job done. Thanks for watching. The next thing I'm going to be looking at probably is either another clock, or I might have a crack at the signal generator, which I ordered. So we'll see. And I've got some more kits on order as well. So yeah, good few more vids to come. In the meantime, that's the oscilloscope. Hope you enjoyed it. Cheers for now.